Machine learning. What is machine learning? Machine learning is the study of computer algorithms that improve automatically through the experience. It is seen as a subset of artificial intelligence. Machine learning explores the study and construction that can learn from and make predictions on data. You select a model to train and then manually perform feature extraction, used to devise complex models and algorithms that lend themselves to a prediction which is commercial use is known as predictive analysis. Question number 2. What is supervised learning? Supervised learning is the machine learning task of inferring a function from labeled training data. The training data consists of a set of training examples, algorithms, support vector machines, regression, naive Bayes, decision trees, k-nearest neighbor algorithms, and neural networks. For example, if you build a fruit classifier, the labels will be this is an orange, this is an apple, and this is a banana. Based on showing the classifier example of apples, oranges, and bananas. Question number 3. What is unsupervised learning? Question number 3. What is unsupervised learning? Answer. Unsupervised learning is a type of machine learning algorithm used to draw inferences from data sets consisting of input data without labeled responses. Algorithm: clustering algorithm, anomaly detection, neural networks, and latent variable models. These are algorithms are example of unsupervised learning. For example, in the same example, a fruit clustering will be categorized as fruits with soft skin and lots of dimples, the fruits with tiny hard skin and elongated yellow fruits. This is an example of unsupervised learning. Question number 4. What are the various algorithms? There are various algorithms. Here is a list. Let's see the list of various algorithms. Machine learning. Machine learning is classified into two types of learning: supervised learning and unsupervised learning. Unsupervised learning is consist of clustering algorithm. Supervised learning is consist of classification and regression. Classification algorithm is support vector machine, discriminant analysis, naive Bayes, nearest neighbor, and neural network. Regression is consist of linear regression (GLM), SVR and GPR, ensemble methods, decision trees, and neural networks. Clustering algorithm consists of k-means, fuzzy c-means, hierarchical, Gaussian, hidden Markov model, and then neural network. Machine learning trees. This is a machine learning tree. Machine learning trees consist of supervised learning, unsupervised learning, semi-supervised learning, and reinforced learning. Supervised learning consists of a continuous target variable, categorical target variable. Continuous target variable example is regression. Categorical target variable example is classification. Example of regression is housing price prediction. An example of classification is medical imaging. Unsupervised learning: target variable not available, clustering and association. Clustering, customer segmentation, and then in association, market basket analysis. So customer segmentation and market basket analysis are example of unsupervised learning, clustering, and association respectively. Semi-supervised learning. Categorical target variable. Its example are classification, clustering. In classification, text classification, and in clustering, lane finding on GPS data. So, lane finding on GPS data is an example of semi-supervised learning. It falls under clustering. And text classification falls under classification. Reinforced learning. Categorical target variable not available. Categorical target variable classification. Its example is optimized marketing. And target variable not available. Control. Its example is fiberless car. Question number 5. What is naive in naive Bayes? Naive Bayes theorem is an example of supervised learning. It is based on Bayes theorem. So the answer is naive Bayes methods are a set of supervised learning algorithm based on applying Bayes theorem with the naive assumptions of conditional independence between every pair of features given the value of the class variable. Bayes theorem states the following relationship given class variable y and dependent vector x1 through xn. Then p of y slash x to n. This represents that probability of y when x to n are given. That is equal to probability of y into probability of x to n when y is given divided by probability of x to n. Using the naive conditional independence assumptions that each xi is independent for all I, this relationship is simplified to probability of xi by y, x1 xi minus 1 up to xn is equal to probability of xi when y is given. Since probability of x to n is constant given the input, we can use the following classification rule. So probability of y by x to n is equal to probability of y into multiplication, this is multiplication sign, probability of xi by y, where I iterates from 1 to n divided by probability of x1 to xn. And we can use maximum a posterior, that is map estimation to estimate probability of y and probability of y slash xi. The former is then the relative frequency of class y in the training set. Probability of y when x to n are given is directly proportional to probability of y into probability of xi by y, where I iterates from 1 to n. This is sign of the pi, that is sign of multiplication. Y is equal to argmax probability of y, then this is the formula. The different naive Bayes classifiers differ mainly by assumptions they make regarding the distribution of probability of y by xi, can be Bernoulli, binomial, Gaussian, and so on. What is PCA? When do you use it? Principal component analysis. That is full form of PCA. Principal component analysis is a statistical method used in machine learning. It consists in projecting data in a higher dimensional space into a lower dimensional space by maximizing the variance of each dimension. The process works as following. We define a matrix A with n rows, the single observation of a dataset in a tabular format, each single row, and p columns or R features. For this matrix, we construct a variable space with as many dimensions as there are features. Each feature represents one coordinate axis for each
feature. The length has been standardized according to a scaling criterion. Normally, by scaling to unit variance, it is determinant to scale the features to a common scale. Otherwise, the features with a great magnitude will weigh more in determining the principal components. One plotted all the observations and computed the mean of each variable. That mean will be represented by a point in center of our plot, the center of gravity. Then we subtract each observation with the mean, shifting the coordinate system with the center in the origin. The best fitting line resulting in the line that best accounts for the shape of the point swarm. It represents the maximum variance direction in data. Each observation may be projected onto this line in order to get a coordinate value along the PC line. This value is known as a score. The next best fitting line can be similarly chosen from directions perpendicular to the first. Repeating this process yields an orthogonal basis in which different individual dimensions of data are uncorrelated. The basis vectors are called principal components.
PCA is mostly used as a tool in exploratory data analysis and for making predictive models. It is often used to visualize genetic distance and relatedness between populations. Explain SVM algorithm in detail. Question number 7. Classifying data is a common task in machine learning. Suppose some given data points each belong to one of the two classes, and the goal is to decide which class a new data point will be in. In the case of support vector machines, a data point is viewed as a p-dimensional vector, a list of p numbers, and we want to know whether we can separate such points with a p-1 dimensional hyperplane. This is called a linear classifier. There are many hyperplanes that might classify the data. One reasonable choice as the best hyperplane is the one that represents the largest separation or margin between the two classes. So we choose the hyperplane so that the distance from it to the nearest data point on each side is maximized. If such a hyperplane exists, it is known as maximum margin hyperplane. And the linear classifier it defines is known as maximum margin classifier, or equivalently the perceptron of optimal stability. The best hyperplane that divides the data is H3, capital H3. We have n data x1, x2 up to xn, yn, and p different features. Xi is equal to xi to the power 1 up to xi to the power p, and yi is either 1 or -1. The equation of hyperplane S3 is a set of points x satisfying y into x minus b is equal to 0. W into x minus b is equal to 0, where W is the not necessarily normalized normal vector to the hyperplane. The parameter b by W determine the offset of hyperplane from the origin along the normal vector W. So for each I, either xi is the hyperplane of 1 or -1, basically xi satisfied wi into xi minus b is greater than equal to 1, or wxi minus b is smaller than equal to -1. SVMs are helpful in text and hypertext categorization, as their application can significantly reduce the need for label training instances in both standard inductive and constructive settings. Some methods for shallow semantic parsing are based on support vector machines. Classification of images can also be performed using SVMs. Experimental results show that SVMs achieve significantly higher search accuracy than traditional query refinement schemes after just 3 to 4 rounds of relevant feedback. Classification of satellite data like SAR data using supervised SVM. Handwritten characters can be recognized using SVM. So these are applications of SVM. Question number 8. What are the support vectors in the SVM?
What are the support vectors in SVM? In the diagram, we see that the sketched lines mark the distance from the classifier, the hyperplane, to the closest data points called support vectors. Darkened data points, the distance between the two thin lines is called margin. To extend SVM to cases in which the data are non-linearly separable, we introduce the hinge loss function, that is max 0, 1 minus yi w into xi minus p. This function is 0 if x lies on the correct side of the margin. For data on the wrong side of the margin, the function's value is proportional to the distance from the margin. Question number 9. What are the different kernels in SVM? There are 4 types of kernels in SVM. Number 1, linear kernel. Number 2, polynomial kernel. Number 3, radial basis kernel. Number 4, sigmoid kernel. Question number 10. What are the most known ensemble algorithms? The most popular trees are AdaBoost, random forest, and extreme gradient boosting, XGBoost. AdaBoost is best used in a dataset with low noise when computational complexity or timelines of results is not a main concern, and when there are not enough resources for broader hyperparameter tuning due to lack of time and knowledge of the user. Random forests should not be used when dealing with time series data or any other data where look-ahead bias should be avoided, and the order and continuity of the samples need to be ensured. This algorithm can handle noise relatively well, but more knowledge from the user is required to adequately tune the algorithm compared to AdaBoost. The main advantage of XGBoost is its lightning speed compared to other algorithms such as AdaBoost, and its regularization parameter that successfully reduces variance. But even aside from regularization parameter, this algorithm leverages a learning rate shrinkage and subsamples from the feature like random forest, which increase its ability to generalize even further. However, XGBoost is more difficult to understand, visualize, and to tune compared to AdaBoost and random forest. There is a multitude of hyperparameters that can be tuned to increase performance.